All right, 7-2, parallelograms. All right. So we have some theorems, properties of parallelograms. We've got 1, 2, 3, 4 on the front of this that we're going to talk about today. And we have our sample parallelogram. We know it's a parallelogram because these two sides are parallel. That's what those angles mean. Those arrows mean. And then these two sides are parallel. That's why they each have 2 arrows. Okay? So we're going to mark this parallelogram up as we talk about our theorems. So the first one is, if a quadrilateral is a parallelogram, then its opposite sides are congruent. Now, it means they equal each other. So side AD is congruent to side BC. And side AB is congruent to side CD. Okay? Congruent means they are also equal to each other. Then if a quadrilateral is a parallelogram, then its opposite angles are congruent. So angle A is congruent with angle C, and angle B is congruent with angle D. Okay? So again, they are congruent, or they measure the same. Okay, third theorem, if a quadrilateral is a parallelogram, then it's consecutive, which means one next to the other, are supplementary. And we said supplementary equals 180 degrees. So consecutive, one right after the other, so right next to each other, A plus B. So you can take angle A plus angle B, and they equal 180. Okay, consecutive. Angle B and C are also consecutive. Angle B plus angle C equals 180. All right, angle C and D are consecutive. Angle C plus angle D is 180. And finally, angle D and A are consecutive. So angle D plus angle A equals 180 degrees. All right, so your consecutive angles equal 180 degrees. They're supplementary. And our final theorem on the front, if a parallelogram has 1 right angle, then it has 4 right angles. Okay, so in that case, those parallelograms would be either a square or a rectangle. Okay, so that's theorem number 4. All right, let's use these theorems. Okay. So it says, given parallelogram ABCD, find CD. Okay, so it wants me to find the measure of CD. Well, it tells me that side CD is congruent with side AB, which means CD equals AB. In that case, it equals 4 feet. Okay. So we can never get away from these, because we have so much fun with them. So again, we're going to do some more. So we're going to complete our 2-column proof. So it says, given parallelogram HJKP and parallelogram PKLM, so you're given that these two shapes are parallelograms. What's it want us to prove? That HJ is congruent with ML. Okay. So our first statement, the reason, well, it's given. Okay, we have one given, and there it is. Now, statement 2 is saying that side HJ is congruent with side PK, and side PK is congruent with side ML. And we go back up here to our properties, and we look at theorem number 1 for today. And it says if quadrilateral is a parallelogram, then its opposite sides are congruent. So that is our reason. So opposite sides of a parallelogram are congruent because it's using our congruent sign. Now, if HJ is congruent to PK and PK is also congruent to ML, okay, then HJ must be congruent with ML. And that is by the transitive, we've been talking about the transitive property for a while now, property of congruence. Because if your first thing is congruent to a second, and that second thing is congruent to a third, then the first thing is congruent to the third thing. Okay? Now, because this is 7-2, we have a new essential question. What special properties do parallelograms have? So you will answer that in the summary. Remember, that is different than the 7-1, day 1 and 2. Essential questions. All right, you'll answer that right down here. Oh, we got a couple of theorems that we're going to learn about today. So we have got, let me see, we learned 4 on the front, so this is theorem 5 and 6 for the day. Okay, your theorem 5 says, if a quadrilateral is a parallelogram, then its diagonals bisect each other. All right, so the diagonals bisect each other. And what that means, if this is A and this is B, then these two would equal each other. Okay, the two halves equal each other when they are bisected by another diagonal. Okay, so A and B would equal each other, and C and X would equal each other. When you bisect, you equal each other. Our sixth theorem for the day. If a quadrilateral is a parallelogram, then its diagonals separate the parallelograms into two congruent triangles. Yep, sure enough. So you got your parallelogram, two congruent triangles. You just have to spin one around. Other diagonal, again, two congruent triangles. Okay? So let's use what we've learned so far with all of our theorems. All right? So it wants us to find the value of x and z in parallelogram ABCD. Okay, parallelogram ABCD. So it says if the measure of angle ADC, okay, if the measure of that whole angle is 4x, and the measure of DAB, okay, this whole angle, measures 2x minus 6, okay. Well, we learned on the front that the consecutive angles, you add them together, and they equal to 180. And so that's what they did here. The consecutive angles add up and equal to 180. So the measure of angle ADC is 4x. The measure of angle DAB is 2x minus 6. Now on this side we have like terms. So that'd be 180 equals 6x minus 6. We'll add 6 on both sides. And what you end up with is 186 equals 6x. Divide both sides by 6, and you end up with x equals 31. Find the value of z. Okay, well, z is a diagonal, and we know the diagonals bisect each other. So that means this side equals that side. Okay, so AE is congruent with CE, so that means AE equals CE. Okay, AE is 3z minus 4, and CE is z plus 5. All right, let me rewrite that so I have a little more room. 3z minus 4 equals z plus 5. Now, you can start by moving any one of these. They all work out the math the same, but I always do the loser with the variable, which is the lowest coefficient of a variable, which would be this one z. So I'm going to subtract z from both sides. That gives me 2z minus 4 equals 5. Then this is a two-step equation. I will add 4 to both sides. 2z equals 9. Last step, divide by 2, and z equals 4.5. All right. There weren't too many stumbling blocks in class on this assignment. The assignment is in McGraw-Hill. A number of people were able to get it done or close to done before class ended, so good luck.